Cool. So what we're going to do is we're just going to plonk that in our directory as .editor config, and when we use that in tandem with the editor config extension, this essentially just allows us to define when to use spaces, when to use tabs, that sort of thing. And so what we're going to do is we're going to copy that little block there and then just tell the editor that anything star.gd is going to be a tab, and I think I'm going to set the indent size to 4 as opposed to 2 because yeah, you can see that's now increased that indent. So the reason for doing that, I think, is just because in Godot, like Python, the indentation has like meaning, and so that means it's a lot more important to visualize and distinguish between the different indentation levels. So I think that's the right thing to do. Cool. So where we got to is we need to define 2 new functions in this class. So we've got a thrust direction and a rotation direction, right? Now, if okay, so let's add some helpers to help us implement these. First of all, we can say is rotating left is equal to input dot is action pressed UI left, right? And then we can duplicate that line and just do a similar thing for rotating right. Okay, so what we're going to do is we're going to say the direction is going to start off as 0, and then we can say if is rotating left, then direction equals direction plus 1, no, minus 1, and otherwise we just change that to a plus, right? And then what we do, that's kind of annoying, is we return the direction. Okay, there you go. And then we do something similar here. We would say thrust direction starts off at 0. Now the reason why we're doing it this way, right, is that often for games you might have, like, especially keyboard input, if you push left and then you push right, you expect those to cancel each other out. Now that's normally people don't notice that a whole lot, but usually if a player is going to quickly change direction from left to right, they might have sort of a bit of a legato where they might push both before letting go of the first key, and we want to handle that, right? So that's why we're doing it like this instead of just okay, we don't need to give that a prefix, so we can say direction if it's equals direction plus 1. Okay, and then we... Okay, I don't know why it's not letting me do that, but okay. So we could return a vector2 here, which I feel is correct. Or is that... We might want to do some some linear calculations on the thrust, so maybe it's okay just having a single number there. All right. Cool. So let's see if we can actually run the game without everything blowing up. Okay, something's going weird here. Oh yeah. Okay. Alright, so let's just try and run the game and see if anything blows up. Okay, so it looks like our thrust direction is incorrect. So our thrust direction is perpendicular to what we need, and then our particles are the wrong way around. That's fine. That's a very easy fix to make. So the thrust direction, if we're going forward, yep, okay, I kind of like that. So -1 would be like -1 on the y-axis, so that would be like moving up. So I think we could possibly even call that, no, it's not up, because up is relative to gravity, I guess, and forward is relative to the player, so I think that's more descriptive. Okay, so then the final thing we need to do is that when we process the velocity, we just flip these around. And I think this is actually going to be in the wrong direction, but let's just check. Yeah. Okay. So negative thrust amount. Cool. So we've got our little spaceship bouncing about, collecting letters. Doink, doink, doink. Trying to build a little message to insult his fellow players. Or maybe inspire his fellow players. Who knows? Okay, and we need to now connect the signals that we added to the player, but that should be easy enough. Okay, so now we have our control state abstracted. We can now go back to our player test and do a little bit more in the stub department. So let's grab this and make a note of that. Okay. Cool. So we can close that one, that one, that one. Cool. Sweet. So I think we are interested now in stubbing. How's everyone going this evening? Are you guys Elixir people, Godot people, cat people? Because if you're more interested in Elixir, we can switch over to do more Elixir. And work on the Godot stuff later, or vice versa. Okay. Cool, so before we instantiate player, I guess we want to stub the resource player control state.gd, and we will stub the is thrusting forward. Oh, actually, we want to move this. So before we do anything, we expect the test engines are on. In fact, we don't have that method anymore. Okay. So let's see what else can we do. I mean, we can just run the tests. Test ready. And just see if we run these things that they don't break. And func test. Oh, we've got our player down here, so we can keep an eye on what the other things we've got there are. So we've got ready, we've got physics process. Right. And we can just pass in an arbitrary delta. Maybe 1.0 is more obvious that it's arbitrary. Or 1, 2, 3. Just make things as obvious as possible. So handle movement and collisions. And we can just pass that one in as well. Okay, I'm not going to use the shorthand. I'm just going to get ugly quickly. Okay. Func handle particles. Sorry, we need to test handle particles. We need to put that test prefix, otherwise the gut tool will not pick it up. Player dot handle particles func process test process rotation player dot process rotation, and we'll just put a 1 2 3 there. In fact, I might extract that now. I've repeated it enough that I think this and we'll call this dummy delta equals 123.0 and then that's going to make it even more obvious what we're doing here. Dummy delta dummy delta. Okay, process velocity is much the same. Now it might feel like this is pretty redundant, these tests, but having those failures early I think will help us. And this also will give us like a place to add to the test later, right? Process velocity func test handle collision. So I'm not sure what I'm going to do about this collision item. What if bar collision is equal to, let's have a look on the Godot docs. Kinematic Collision 2D. So I'll see if I can do .new here. Cool. Okay, update tail. And that is going to be quite an interesting one. I think that's basically the main thing that we were struggling with before that made us add the test framework to begin with. Right. So we're going to say update tail. And I think, okay, I think what we really need to do is say tail.update, right? Maybe? Update with don't know. Oh, hold on, no. update tail. Yeah, okay, so I guess, so the tail, we're actually not talking about the tail component, we're actually talking about the tail data, which right now is just a string. So it's basically a string of all the characters you've collected up until now, right? Okay. Apologize, my voice is going funny. I'm going to say with collision result, right? Right, because the thing is we're updating the tail in lots of different places, so I think we should probably be a little more descriptive there. So I wonder what the Godot way of extending strings. Okay. Okay, so we could create a new type and do it in there instead. So we created this type, which is a our collision result, and let's just add a class comment here. Collision result encodes the effect a collision collision result encodes the effect a collision should have on a player, right? So right now we're just having so if you collide with a bubble, we say, well, you should add a particular letter to your tail, and if you collide maybe with an enemy, you should subtract 1, 2, 3 letters from your tail, right? So some enemies can be more dangerous than others. Okay, so we're going to do something similar here, and we're going to create a new type, and we're going to say this is a tail state. Okay, and this extends reference as well. Reference. Okay, and let's put a comment up here. What is this? This wraps the contents of a player's tail. This wraps the contents of a player's tail. We do extend string. Maybe that's better. No, actually, okay. I think I know what we want. So we want a reference, right? So the var tail contents is a string, right? and then the var. Well, okay. So first of all, we've got a length, which is going to be equal to the tail contents.length. Right. We are going to have a function called invert. Right. And that is going to do what we struggled to do before, because for some reason Godot doesn't implement a reverse function on strings. And should we say that returns an int? How do you do that in Godot? Godot specify return type. Oh yeah, that's the single arrow. Okay, so length should always return an int. Invert should always return void because it's a state change. And cool. All right. So now what happens is we go, see, we're slowly pulling the player apart, right? So let's grab some of these. Okay, I'm just gonna get rid of some of this stuff. Okay, so the var tail is no longer, we'll call it a tail state. And it's no longer just that. It is a tail state dot new, right? And we need to load the tail state class. So we will load that next res types player no, tail state dot gd. Okay. And now whenever we update the tail, we want to pull that logic out of the player and then move it into this class, I think. Okay. Here we go. So this update tail with collision result is tail state dot update with collision result, right? And then all of this moves into our tail state func update with collision result, and we'll just say that's equal to collision result. And we paste all that in. Oh. And then that becomes the tail contents. Tail contents. Cool. All right, and that should return void. starting to cool down out there. Still quite warm. Yeah. And then dot contents. Okay, so I'm going to actually rename that contents, because we're already in the context of the tail, so we don't need the prefix, right? It doesn't give us any more information. Okay, so what you'll notice here is that we're pulling our parts of our data model out of the player. So our data model is in the tail state, but we're still leaving the manipulation of the resources and the components in the player object, right? So we want to make that distinction, right? Which of our classes model our state and the data model, and which of our classes do the doing, and trying to keep those separate. Okay, so the invert is going to be weird. It's like so that's going to be just like contents, and then that's going to be like new contents, and that's all of this. Is just going to be new contents. Cool. And contents like that, right? Plus contents. Okay, I might try and go back to the previous method we tried that failed. But I mean, like, in the documentation it said it should work, so I don't know why it wasn't, but okay, so invert tail is no longer interesting on this class. This can die. And in fact, we could probably put these side by side now. Cool. All right. So, as you can see, this has cleaned up our player class quite a lot. Update with collision result. Maybe that should just return the contents. In fact, yeah, I like that. It's not command query separation, so yeah, we'll leave it. Okay. Don't know whether we keep that space. All right. So now this player state. Let's go up here. Alright, that's kind of more useful, isn't it? On the right hand side. Okay. All right, so we're going to implement this invert tail. So what we're going to do is we're going to say var the letters are going to be equal to the contents dot split with an empty string. Then we're going to call letters dot invert, and then we're going to return letters dot join with an empty string. So that's the simplest. Oh, and then we can say contents is equal to letters.join empty string. Right. And here we can say before is equal to the contents, and here we'll say after is equal to the contents. Now last time that wasn't updating, and I don't really know why. The Godot documentation says it should work this way, but it doesn't seem to. I might get rid of this mini map. It's not really helping me. It's getting in the way. What is it called? Sidebar? What? Alright. View minimap. There you go. Okay. That gives us a little bit more space. Alright, so now we can actually just write a test for this tail state. Okay, so I think our first test should always be, does the code run? And it seems to, and cool, that tail state is already working. So we didn't, looks like we didn't get anything wrong there. Oh man. I'm useless at this. Okay. Plonk. Okay, and then now we need to maybe hook up the events next, but that'll come in time. So let's run our tests here. So we had 8 tests, 0 passed, and 0 failed. Okay. So let's have a look here now. So the player ready, we should assert has control state. Why is that? At least 2. Okay, let's just check what our asserts are here. Still new to this test framework. Assert accesses maybe? Object property default. Yeah, no, not really what we want, I don't think. Almost equal, no. I thought assert is or has. Assert has object, element, text. Assert has array 4. Oh, okay, no. A hash 1. Okay, no. Not what we want either. So we could just assert is on the oops. Assert is, I guess, allows us to assert the type. So yeah. Cool. All right. So what I think we're going to do in our test is we're going to assert is, and we're going to just say we expect the player dot control state to be a control state, and of course we're going to have to var control state is equal to load res player control state.gd, right? So we load that class and we just say call ready on the player and just assert that the control state is a control state, right? When we test the physics process, should we just assert that the player dot rotation velocity assert equal, so the rotation velocity should be 0 because we're not setting anything. Then handle collisions. I think that's a fair assertion to make. So these are kind of empty assertions, but I think it does just make sense. Okay, so particles dot emitting. So because we're not pushing any buttons in our test, so we should assert that by default the player dot particles dot emitting is equal to, oh, just assert false, right? So when we call handle particles, we're not going to be, is thrusting is not going to be correct. And I think what we can do is we can stub the player dot control state, and we'll stub the is thrusting to return true, and we'll put it down after the initial assertion, right? So what we're going to do is we're going to say handle particles with no input, and we'll say, well, with no input it's obviously going to be false, right? We're not going to be shooting thrust out of our space bottom. But what we do then is if we stub the control state to return true, then we can reassert, we can rerun the handle particles and reassert that it's actually true. Process rotation, well, here we can just say that the rotation velocity should just be 0 by default, and there as well, and there as well, and we don't have an update tail method anymore. Okay, so let's see if we actually get some passes. 4 passed, 0 failed. Fantastic. Alright, so we now have perhaps not extensive tests, but a pretty good sanity check on all of our functions on the player right now, right? Except maybe shoot. Well, we haven't implemented that quite yet. Okay, so I'm going to commit this because I think we've come a long way. Okay, so this file here, we'll just commit that and say added editor config. And here we can say extracted control and tail state into their own classes, and added rudimentary tests for player class. And what was this? Update test scripts to show orphaned reader nodes. Okay. Okay, so let's push that up. So when my MacBook, my old MacBook Pro bursts into flames, we don't lose anything. Cool. All right. So the next stage is we want to figure out a way to hook up our control state events. So we've got shoot and invert, right? And what I'm going to do is I'm just going to print shoot in. Oh, let's keep that open. Close that. What's this complaining about? Connect returns a value that's never used. Oh man. Okay. So this is just a little bit of a hack to just assume that all of our connections here are going to work. And this is what we're going to do on the player. So I think we can actually write a failing test here before we implement this code, which is quite cool. So what we can assert, I think, is something to do with signals. Let's just have a look. Assert assert connected. Asserts that the signaler objects connect to the connect to object on signal name. Okay, yeah. So signaler connector signal method. Cool. So in our test, when we run player.ready, oh, it's supposed to be underscore ready. Why are these? Is that going to complain? Not really? Okay. So let's get a failing test under ready. So we want to assert that the control state is a control state, but we also want to assert connected. Right. And the signaler is going to be the player.control state. The connector is going to be the player. The signal is going to be player_shoot. And the method is going to be shoot. So what we're asserting here is like, make sure that when the control state fires the player shoot signal, the player.shoot should be listening and respond to it, right? Now, when we run this test, it should fail. Cool, one failure. I love it. I love it. Testing, guys. Testing is like how you make programming zen. I mean that. This is the only way you can make programming zen, is by embracing testing. I can love a good test. Not even being sarcastic. Okay. So now we've got our failing test. How do we make it work? Well, easy enough, right? We call connect, right? And we connect the signal player shoot. Connects a signal to a method on a target object pass. Optional binds to the core. So we want to go control state dot connect, right? So we're going to connect the player shoot signal to self, which is the current class, which is the player, or current instance of the player, and then the method is we're just going to do shoot, and the binds, I can't remember what the binds does. Godot connect signal binds. Binding arguments. Oh yeah, that's the arguments. Yeah, that's right. Okay. So we don't need any additional arguments on that method, and in fact that line is short enough to just slip nicely in there. And now when we run our test, we get green, right? We are also getting a memory leak of sorts, I believe. Resource still in use. Control state. Okay. So here, Godot on destroy. Deconstructor. Void exit tree, yeah, that's the one. So we're just going to implement exit tree. And we're going to say control state dot free. Right. Cool. Not quite what we're after. what can we do? Godot or GD script. Life cycle events or callbacks. Okay, here we go. So scene tree processing. Okay. Finally, when a node is freed or queue-free, it will also free all of its children. Okay. Interesting. I mean, in our test, we could just say func after each player dot control state dot free. I don't know if that's. It feels like that is a cop out, but it works. So you know. I guess what we could do is say control state here, and then just do add child. Control state. And then I don't think we need this, because as soon as we add it as a child, our player will, nope. Add child. Screw it. We'll just do it the dirty way for now. It's just the tests that are complaining. So, and okay, sweet. Whoa, what's happening up here? Okay. Can we just like auto free the player dot control state? Does that work perhaps? Not quite. Leaked instances typically happen when nodes are removed from the scene tree with removed child but not freed. Okay. Thought that was working before. Resource still in use. Okay, resource still in use. author nodes. Okay, let's have a look at our control state. Maybe we just... Is that going to work? Become a reference? Instead of an object? Okay, cool. And then I think what we need to do at the beginning of the test is just add the player to the tree. So player add child player. Maybe. Node not found. Tail, that's fine. We don't want the interesting. I wonder how this Godot test framework expects us to handle this. These are all videos, they are. Okay, well we can subscribe and give them a thumb at the very least. So what I want to know is how on earth do we just want to like abort the test, like if we get any script errors? I guess the script errors are fine if they're not clashing with our assertions. I don't know, let's have a look. Godot gut node not. Maybe we should just get tree. So like get tree dot add player, right? And maybe instead of doing that, we grab the whole scene and do it that way. Okay. Okay, let's figure out how we are loading the scenes in Gut. Any questions or comments, please don't feel shy about bringing them up in chat. If there's anything you want clarified, let me know. Godot got load scene. Okay, we want some of this. Save this. Okay, let's have a look. Godot load scene. Do we just instance the scene? Root.getNode. Root get, maybe what? Get tree dot root dot add child. Is that going to work? So I think the issue we're having in our test is that we need to load the player. Change scene. So we load, we get the instance. Okay, I see. So the player scene is like that, right? And so we instance it, get tree dot, and then okay, so then we get the player scene dot instance. In fact, hold on. Jesus Christ, man. Doing my editing. Okay, so we call this player scene dot instance. We get the tree, go to the root, add the child, player. Okay, cool. So now we've got a shitload less errors. Okay, so that's what we wanted to do. Let's copy some of that code and make a note of that, because that looked like it was quite useful, quite a useful pattern. All right, Sweet. Okay, so now we can go down here. Got float real but inspected int. Loading resource. Test process rotation. Test. Oh yeah, delta is supposed to be an int. Okay. Maybe? Don't know. Process is not. Yeah, we don't have a process, so we don't need to test it. Okay. I'm liking this this test stuff. I think having the test framework is making a big difference to our workflow. Okay, so we're loading the tail state. They'll get there on base reference control state GD. I don't know what that means. Don't know what that means. Make key. Wow, my laptop is burning up right now. Let's get kill Docker. Why am I running Docker anyway? Let's quit Docker. Okay. Make key from metadata. Validate gut on reference control state. Test handle particles. Okay. Stub player.control state. Maybe we should debugger. No, breakpoint. Debugger is JavaScript. Okay, so that didn't work. Why didn't that work? Oh, I forgot to push -D. So -D enables the debugger. Cool. I'm just going to bring this up here. And we're now in a script here. So let's have a look. What does player look like? Locals. Members. Util summary fill gut. Player kinematic body 2D. Yep. P player. P player dot control state. Okay. Global. None of this is really working, is it? Player dot is kinematic body 2D. On reference. Okay. So I think what we can do is if we remove this breakpoint, right? Then I think it's gonna come up, yeah, whenever there's an issue. So if I say now player, p player, print player, stubber, I'm a little bit confused, I'll be honest. Test handle particles. Stub player dot control state is thrusting. Stub thing p1. So the thing to stub okay, so let's just assert has method and object method. Okay, so let's assert that the player dot control state has the method is thrusting, right? Test physics process. And that's supposed to be 0.0, I think. These are floating point numbers representing our velocity non-discrete values. Okay, so we're slowly getting rid of those warnings. Handle movement and collisions. Rotation, velocity. Dummy delta. Got int but expected float. I don't know what that means, but okay. I mean, they're just warnings. Okay. So our members are what? Not much. Our locals doubled. Test handle particles. Player.handle particles. Assert false. Player.particles emitting. Assert has method. Stub. The method name if an inner class subpart. Right now we cannot. Okay. I mean, okay. Let's just remove that part of the test. You know, like, I think just doing the assertion as is good enough. Fantastic. So we've got 3 warnings now. We're slowly whittling it away. So test process velocity. Okay, so the velocity. So the velocity is a vector 2. Oh. Okay, I know what's going wrong. Okay, so the rotation velocities are all floats, and then the has method player 58. If not collider. Okay, cool. If not. Okay, I guess we just need to provide a collider for it. which is fine. So when we test handle collision, where is that? Outline. Maybe it is better to have that down here. So test handle collision, right? So we're making like a multiplayer space game. I'll show you a quick demo. So the idea is that I want it to be like a massively multiplayer online game. And so like the core, it's a little bit like Snake. Like we're going to have like a chain of letters, and we're going to have like a maze, I think. And then players are essentially going to go around the maze trying to build messages. And then you can shoot and interfere with other people's messages. And then so you just go around collecting letters, trying to spell stuff to sort of communicate with the other people around you. It's kind of silly, but we're going to use it as an example for building like an SDK for massively multiplayer games in Godot, and then hopefully make that available so other people can do something similar. So right now Godot's amazing for like simple single player games, and then it's pretty good for doing like LAN games. However, I don't think there's a lot of support for like an authoritative multiplayer server yet. And so you can see we're actually down the bottom here, we're actually trying to connect to our Phoenix server, which I've disabled while we're doing this. But yeah, cheaters, that's what we're doing. And this is the Phoenix code, which I've copied from some dude. I can't remember. It's under Phoenix, Godot Phoenix channels, I think, on GitHub. He's published it, but it's not published as like a full asset lib plugin yet. So we're probably going to fix up a few issues with the network code and hopefully publish that with his blessing. But I want to just add some unit tests to the game so that we can just improve our workflow a little bit. And I'm a bit new to unit testing in Godot, so it's been a bit of a journey, but a fun journey. Okay, so the reason why this handle collision is throwing a wobbly is because we are creating this collision without providing a collider. So what we could do is just do collider, collision dot collider equals node 2d.new perhaps. Is that going to get rid of the warning? Invalid set index collider. Oh, what? Collision dot. What does this new allow us to use? Collision dot I mean, we can just stub. Right, so let's just stub collision Oh god. Collision dot yeah, you can see I'm getting tired now. Collision collider, stub it, and then to return. We'll just say player. We'll just say players. We'll pretend like the player's colliding with himself. What? I don't know what this is supposed to mean. Let's give it a quick Google search. Quite useful. Okay. Okay, so test process velocity. So I'm gonna move on to something else and see if I can solve that, and then come back to this. So test handle movement and collisions. So if we make that an integer, is that going to complain? No. And then process velocity. That then is not going to complain. Okay. Handle collision. Oh, that's interesting. Okay, so bar speed, rotation velocity is supposed to be a float, and we initialize it at 0.0. Okay, so that's why it keeps complaining. It keeps switching types on us, and that's why we're getting the weirdness. Okay, and then that means now we can keep asserting everywhere that it's a float. Right. There as well. Cool. We may as well just assign types to all of this stuff. I don't know if that makes a big difference or any difference on the type system in Godot. I'm still a little new to that. If anyone's familiar, I'd be interested to hear. So the control state is going to need to be a control state like that. That's fine. A node 2D. and that is meant to be a node 2D as well. Oh no, that needs to be a CPU particles 2D, and that tail is just a node 2D. Yeah, okay. What's that complaining about? The event isn't valid type, not. Okay. 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 Whoa. What happened to the control state? What? So the control state is not getting set somehow. Bar control state. If we just do like control state like that, is it not? Control state's there. Alright, if you insist. Wow. What? For each layer. Huh. What did I change? That's kind of confusing. Okay, so this is an obvious fix. So fix return values in socket connection, signal connections. Right, so that's an obvious fix. I don't think that makes a big difference. Control state to connect. Okay, huh. At which point does it start shitting itself? Process invalid call, non-existent function, non-function. Okay, so let's just try and run it from the game itself and figure out if the problem lies in the test or trying to assign value of type label to a variable type 2D. Okay, that's fine. Oh, I see, I see. Okay, we broke it. We broke it there, and that broke it everywhere else. Okay, that's fine. Cool. Okay, I think I'm kind of done with testing. I think it's made. So let's just get these running again, and then make key from metadata test handle collision. Is there anything quickly we can stub collider? Has method. Okay, so we've only got one warning left. Okay, I'm not going to stop now. So close to having like a nice clean test run. And it's going to all be worth it in the end. I promise you. Promise you. Look at that green. Doesn't it just make you feel all warm and fuzzy on the inside? So what we could do is we could just check if the collision has a collider, right? So if collider and so it make, I think that's fine, right? And then handle collision, we don't actually need to do the stub anymore. I mean, it does mean we changed our code to suit our tests, but fuck it, no one's watching. Okay, attempt to call on collide with player in base null instance. God damn it. Okay, I think we're gonna have to look into this kinematic collision 2D. I think it's called. There we go. And figure out like what we do about this. So how do we create one of these things ourselves? Get collider. Okay, I know why it can't stub. Silly us. We should have been, yep, okay. So we're supposed to be calling get collider, right? That allows us to get the collider. Now we don't have to do this check, right? And then here, we don't stub the collider because collider is a property, not a method. So we stub the get collider method to return the player, and then all is well with the world. Nope. Something else went wrong. What? So frustrating. What? Come on, come on. I just want to put a collider in there. Collider shape. Okay, can we stub? Oh, let's just create a double instead. That's what we want to do. Okay. So instead of creating a collision like that, let's create a collision which is a double of the thing, right? And then call .new on that, right? And then can we stub it? As method on null. Get collider to return player. The normal vector 2 must be normalized, and that's fine. How do we... Oh, there we go. I think we're nearly there. Okay. So we double the scene, double stack method, doubling built-ins, double... Okay. So then all we do now is we grab this collision and we stub the collision normal, right? To return a vector 2, and we'll just return an empty vector. In fact, no, we won't. We'll return the identity vector, and then normal vector 2 must be normalized. Oh, well, we can normalize it by just putting it in one direction. Dot normalized, if you insist. The normal vector 2 must be normalized. I did normalize it. Fucking did, look. Did it. The normal vector 2 must be normalized. Oh. I bet we also need to stub collision dot get collision normal. Wait, let's have a look. What else are we doing here? So we could stub the velocity dot bounce, right? Stub player dot velocity bounce. Okay, and then we should be all green. No, test handle collision. Oh, come on. Okay, dash D. Okay, core math vector 2 C++. Okay, so let's open Godot in GitHub and read the source code. I'm a bit rusty on C++, so but we're going to try. Godot engine Godot, and it's under core vector 2 somewhere. Vector, was it? Core math vector 2. Core math vector 2 C++, and line 201. What are they trying to do? So they're trying to subtract a vector 2. Is that really where the error is coming from? Reflect. Okay. Here we go. I mean, okay, we could stub the reflect method, right? Instead, and see if that makes a difference. Reflect. Okay, let's have a look at the vector2 class here in the documentation. See what we can find. So reflect takes a vector2, returns the vector reflected from a plane given fine by the given normal. So Kinematic Collision 2D. Kinematic Collision Let's just copy this. Okay, but get collider velocity normal position. We're so close. We're so close. So we double it. We return that. Turn that. And then okay, those are just operations. Reflect, math checks, error condition fails. If P normal is normalized, the normal vector 2 must be normalized. P normal, okay, so we're P normal. But that's like literally what we've done, right? So I mean, we could just call like normalized here, I guess. No. What am I doing wrong? What am I doing wrong? The normal vector 2 must be normalized. Maybe you can't normalize an empty vector. One. Okay, what if we just print that and see what happens? Normalized, right? So it should be like the, I don't know what it should be actually. 0. Yeah, so it's like the square root of 1, right? And then if we say if we put the vector to 0, 1, it's going to normalize it to 0, 1, and that should be a normalized vector. 0, 1. So then it's fucking normalized. So why are you complaining about it? Oh, okay. I know what I'm doing. I know. Oh no, I'm not. No, I've already done it. I mean, we could stub this as well. Like, this is getting kind of ridiculous, but say like the normal, right, is equal to a double of a vector 2, right, dot new, and we'll pass in 0, 1, and then we stub the normal reflect method what's it complaining about now? Why are you red, bro? Error passing expression. Okay. Otherwise, I think I'm giving up on this test. Invalid call. You know, we can't do that. Jesus Christ, man. Jesus Christ. Okay, I think we're just giving up on this test. Right? Invalid call to base reference normal to return. To return player. Okay. I mean, the test is passing, so it's really frustrating though. I want to understand it, and I can't. So let's run through this again. Velocity.bounce. Oh shit. There's an easy way. There's an easy way, right? So all we've got to do is stub the player velocity bounce method, right? To return. Can we just to return? Come on, baby. Come on, baby. Nope. Oh, sorry. Dot velocity. Come on, give me green. Give me green. I spent far too much of my life on this. Oh, for fuck's sake, really? No, don't return. Don't return. Oh, you cunt. Still complaining. Okay, I don't know how to stub that then. So essentially, like, we're only doing this one line, this velocity bounce on the collision normal. And we don't seem able to set the collision.normal, or can we just, maybe we couldn't set it before because we weren't normalizing the vector. So if we set it to a normalized vector, right? Does that complain? Yep, invalid set index with type vector 2. Stub collision normal stub sensor class. Okay, maybe I'm not understanding this whole doubling stuff. Doubles. Can we just subbing star Okay, yep, no. Life is too short. Life is too short, guys. So how do we short circuit this? I mean, we could actually do. Okay, I've got another idea. I don't want to give up. So instead of returning the player, what we can do is we can pull the bubble and run like the more intricate code in, right? So let's bring these loads up top here. So if we say var bubble is equal to the load of the level objects collectibles level objects collectibles bubble.text scene TSCN text scene. So we load that scene, and actually let's call this a bubble scene, right? And then what we do is we say the var bubble is equal to a double of the bubble scene dot instance, right? And then instead of returning the player, we return the bubble, and we no longer have to stub that. And then have a look. Oh, yes. Okay. All right. I'm gonna commit that. All right. Nice, clean test. Green. What do they say? Eat the frog. If I just did it the hard way to begin with, it would have just worked. This is because I was trying to be too lazy. That was my problem. Okay, cool. Well, it's good. So now we can say implement unit tests for all player methods. Cool. All right. So now we're gonna do a little bit of fun stuff. As if testing wasn't fun. It is, but it's even more fun. Okay, so now I'm gonna start building our chain. So all right, so I'm gonna create a folder under the player, right? Because only players Yeah, only players have chains. I'm just thinking about when we have multiplayer, we're going to have a player and then we're going to have an other player, I guess. Like remote player. But they should both still share the same chain object. So, cool. So let's start a new scene and we'll call this chain. Chain, chain, chain. Why isn't that not working? Chain. Oh yeah, sorry. I always forget that. So we can't save a scene until we actually give it a node. So the chain. How are we going to model the chain? I'm guessing the chain is going to be based on. So it could be just like a node 2D at the root, right? Yeah. Node 2D at the root. And then the chain will be made up of links, I suppose, like chain links, and those will have letters inside them, right? Yeah. Yep. Okay. I think. Yep. That makes sense. That makes sense. Okay. So the main chain is just going to be a node 2D, so we can save that. And then we can create another one in here, a new scene, and we'll call this a chain underscore link. And that is going to be a rigid body 2D. Let me think about this. Yep. Okay. So, yep. So each link in the chain is going to be its own rigid body, and we can see there's a little error up on the left there, and it says this node has no shape, so it can't collide. That is fine. We will add a shape to it. Oops. Which it's sorry, just thinking. Okay, yep. Cool. So we'll add a shape. Collision shape 2D. Right, and then this needs a shape, and we'll add a circle shape. And if we open this up, the radius, I think the radius would be about 25, right? And let's zoom in a little bit here. And then I guess underneath this rigid body, we'll add a sprite. So we can see the link. And if we have a look at let's bring up our file system and have a look at the resources that we have available. For our game. Okay. So I quite like these effects, maybe. So that's our little putt-putt. Okay. Oh, I shouldn't do that yet. So I was just thinking we can take these little clouds and turn them into an animated sprite. And then when we thrust, when when we thrust, then we can, instead of shooting just little white squares as the particles, then we can actually use these little puffs of smoke and animate them, so they're like poof, 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 poof. That'll be really cool, but not now, not now. What else have we got? So we got some missiles. We could maybe repurpose some of these to look a little bit like a chain. Not really. They're all quite phallic, aren't they? Parts. I think my neighbors are having an argument outside. The joys of South London. Oh, that's quite cool. Oh, yeah. Yeah, I'm feeling these, something like this. These little, like, which one's got the right shape? Okay, I think there's some violence happening outside. Okay, we can have like a dark chain, and then have light letters, like white letters, which I think will be quite cool. Okay, what else is in here? Rocket parts. Ooh. We could just have simple circles. What else is there? I think I want them to be quite long and thin. These are just little dudes, aren't they? Look how tiny and cute they are. Okay, so I think we want some of these parts, one of these dark parts. And we want something that's quite long and thin. That kind of looks like a chain chink, is that what they're called? Well, that one's quite good. That one. Okay, I quite like this one. Okay, so we're going to use this. I don't know why I'm caring so much, because we're going to change the graphics eventually anyway. Okay, so this goes in here under the chain, plonk that down, and we'll call this the chain link. Right. And then we can save the scene now. So we grab this chain link and we're just going to drag that into the texture. Here we go. And now I think the collision shape needs to change from a circle to a capsule. Or we can make it the polygon. I think the capsule's easier for us to visualize. Make about 25. Yeah, because we want it to be quite easy to hit. So we're going to expand that. Cool. And then we just need a label in here. And we'll just put an A in there to start with. And we want to align center and center. Always uppercase. always visible. We want the size to be maybe 40 by 40 and minus 20 by minus 20. Okay, so we're like perfectly in the center there. And then I guess we want to just make that font a little bigger. Custom fonts. New dynamic font. And GUI font. Okay, hinting, no hinting, no anti-aliasing, no spacing. Let's make it really big. Maybe even bigger than that. 48. Yep, I like it. Cool. Fantastic. Okay, so we're just going to add a little script to this chain link, and we're going to say on ready, on before that. So we're going to say an onReady variable of $label, var label equals $label, and when you're ready, and then, oh yeah, we're going to export a string, oops, capital S, string variable. So we went over exports before, and we're calling this the character, and we're going to start it off as empty. Right? What are you complaining about? Nothing. Cool. And then when we load this chain link, we're just going to say label.text is equal to the character. Okay. Cool. Okay, and we're going to need one more little thing. We're going to need a joint. Not that sort of joint. Oh, what's that? Subresource. I haven't seen that. Subresource. Subresource. Oh, yeah, okay, yeah. Okay, so we need some sort of joint 2D. So the pin joint would work. So pin joint would just... Yeah, okay, I think a pin joint would actually work. Okay, and so the pin joint is always going to be at the very tip, and it's going to pin this link onto the one before it, right? So let's go into this. So the node A is always going to be the rigid body 2D, right? And the node B is going to be assigned at runtime. Bias. Move in different directions. Bias can have us. The lower the bias, the more can pull on the joint. Okay, so we'll keep the bias at 0.5 maybe. It's about halfway, and then we'll see how that affects. Disable collision. Yeah, we'll need. So that means one link can't collide with the one it's connected to, right? And then we need to transform this slightly. So let's go up by about 30. Cool. Nice. So that's our chain link. And then the chain. So we're going to add a script for chain. And what are we going to do here? Well, we could have a function called add link. That's going to take a character, and what it's going to do, well, we're going to say var link is equal to load. So we're going to load the player chain underscore link dot text scene, right? And whenever you want to add a link, then you say add child. What's the difference? Oh no, add child link.new. Okay, and we're going to say var links is equal to an empty array, right? And we'll say next anchor point, right? So you say if links dot length links dot length is less or equal to 0, then return self. Or maybe, in fact, hold on. What we'll do is we'll create a... What will we create? Okay, let's create like a sprite. And this is going to be like the first link. And maybe it'll look a little bit different. So let's go into our assets and find something a little bit different maybe. Like that. Maybe having it start like white might make sense. I don't know. Screw it. Let's just get something in there. Alright, let's just start white, shall we? And then it'll be more obvious. The contrast will be more obvious. And we'll make it that curved one, so that's like more of a stark contrast with... Yeah, we'll see. If it doesn't look good, who cares? We'll change it later. Okay, so instead of that being a chain... Oops, what did I just do? Okay. I didn't mean to do that. I don't even know what I did. Okay, so we want the chain, and let's create a new tab. Jesus, okay. Going all over the place here. Alright, so parts, where was that? Like round bit there. Okay, so we want to just copy that into there, plonk, and we'll call this chain underscore start, right? And now what we're going to do is we're going to just drag that chain start here under the texture. And let's zoom in a little bit. So I don't think the chain start is actually going to have a collision shape, but it is going to have a joint. Damped. No, just a joint. Joint 2D pin joint. Okay, and let's transform that a little bit up. So maybe -20 or -30. I kind of want to go even further, like, yeah, okay, cool. Sweet. And so that joint is going to always be attached to, oh, so we do actually need, okay, so we're gonna turn this node change type into a static rigid body. Always forget. Okay, rigid body, and then we need a collision shape. Add child node collision shape. So we just want a simple collision shape again. Yep. And I guess we're just going to get a capsule for that. And make it about, what, 20? 40? Think about that, and 15. Yep. Maybe move that down slightly. So we're just going to grab this transform and just move it 5 down. Yeah, I think that embodies the collision shape pretty well. Cool. Alright, so if we go into the player scene, I think what we can do is we could probably just add the chain start in from the very beginning, or the chain itself, right? Click. And let's, what is that? Is that this thing? Oh, hold on. Let me undo that. Let's give these things proper names. Okay, so this is the chain. This is going to be the chain link. Okay, this is the player. Oh, oops. Let's delete that. Okay, so we're going to give this here the chain, and let's have a look at the transform. So on the y-axis we want no transform, and we want a 90 degrees rotation, and I think probably about -70 will make sense for us. Maybe. Okay, and then let's see, editable children. So if we go here, we assign that to chain, and that to the player. Okay, and let's see if that follows the player around. Whoa, hello. Alright, we need some sort of dampening on that chain. Maybe we need some extra colliders to stop. Okay, I don't know why the chain's going a bit crazy. Okay. How do we dampen this? Maybe we don't disable the collision. Now what happens? Okay, so that feels better. Oh shit, no. Okay, maybe we need to put the collision shape further back behind, right? So, and maybe make it a little bit smaller. So that way like it'll be more difficult to collide with the player, right? Yeah, there we go. I don't know why it's going crazy though. Why is it going crazy? Okay, so I think what we need to do now is inside the chain we've got this pin joint. So we always assign node A to the chain, right? And let's put the bias right up. And disable collision off. Softness. The higher the value, the more the bump to the pin button. Okay, so we'll add a little bit of flex in here. Okay, and if we go back to the player, let's have a look. Meow. Meow. Cool, okay. So now we just need to make it so every time we collide with the bubble, we add an additional link to the chain. How are we going to do that? That should be easy enough. Alright, I reckon we can do that. I'm going easy, mate. I'm going easy. So we're going to need, in our player, we're going to need a reference to the chain, an onReady reference. So we're going to say onReady var chain, and that is a rigid body 2D. Rigid body 2D. Oh, my poor old little MacBook is starting to chug. Okay, so the chain is equal to that. And then what? Alright. So every time we handle collision, tail state, update with collision result, right? And what could we do? We could say chain, we could pass the, okay, that's what we're going to do. We're going to update this the tail state with the collision result, then we're going to pass the tail state into the chain and say, hey chain, you deal with this, right? So the player doesn't really need to know much more than that. We just pass it on, right? Yeah. Okay, cool. So so the chain, instead of add link, Jesus Christ, what's using up my CPU? I think it's just a really warm evening. Okay, so let's say func set tail state, right? And we're getting a tail state, which is in fact a tail state. And we just need to load that up here, that class. Res types tail state dot gd. Fantastic. Okay. Oh, that needs a colon there. Okay, and so okay, let's just remove all this. And we can say like what print, we can just say setting okay, so let's say if links dot length is less than tail state dot length, add link. So we're going to be a little naive for now because right now we're only adding one letter at a time. So we don't have to be clever yet. Right? So we add link and, or hold on. If links are, so if we've got too many links, then the first thing we're going to do is we're going to remove redundant links. Redundant links, right? And now we can be naive here because we're not actually removing anything for now. So this is essentially just a placeholder. Oh man. Remove. Redundant links. And that's just going to be a pass for now because we're fans of naive programming. What's this complaining about? Tail state. Okay. Why is the Windows server taking so much? I might just turn off the particles. Another resource is loaded from path. Okay. We don't need all of this just yet. So okay. We don't need that anymore. We don't need to show that. We don't need to show that. Okay. Okay, so what are we doing now? Set tail state. So the first thing we do is if we've got too many links, we just remove the redundant ones. We'll figure out some sort of loop. That should be easy enough. Okay. Then the next thing we do is we okay. We grab the tail state, right? And we get the content, I guess. Contents. And we split. So we say var letters. Oh no, what we're going to do is we're going to say letters, right, as a method. And we're going to implement that on the type. Right, so we can abstract this. So what we're saying here is func letters is just going to be, it's going to return an array, right? And we return contents.split on an empty string. Allow empty. What? Splits the string by a delimiter string and returns an array. If max split is specified, it defines the number of splits to do from the left up to max split. Yep, okay. The default value is 0 means that all items are split. Allow empty. Pull string array. Pull string array. Okay. Allow empty. I think we allow empty, right? Okay, so that's actually going to be a pull string array. And we're going to say true to allow empty. Okay. I think that's correct. Okay, so these are all just like one-liners, so we can condense them. Okay, and then we forgot to put this in, so we're going to say chain dot set. What do we call it? Set tail state, and we'll just pass in the tail state there, right? And now we have our letters available to us, right? So in the chain we can go tail state.letters. Let's Godot for loop. Let me just refresh on the loop syntax. So okay, yeah, I think I know what we're going to do. So we're going to say var letters equals that for I in range letters dot size. So we're going to say ensure chain link with I, and we pass letters in and I, and here we say ensure chain link, and we get letters and I here. And what, let's just actually pull string array, just make sure that if we get this in the wrong order it will be really bad for us, so it's nice to just add some type safety there. And this is going to be a void function. I think this is going to be a void function as well. Okay, so what are we going to do? So we say if links dot length or size, links dot size is less than I plus 1, create link with letters I, right? And here we have a create link function that takes a letter, and we will say next link target dot, we can say, okay, var link dot new instance. So new link is an instance of link. We add child, the new link, right? And then we say new link dot attach to the next link target, right? And then the func next link target is always going to return a link. Oh no, we don't know what it will return. So if links dot size, is there an empty? If link's empty, then return self, right? So if we don't have any links yet, then the first link should always just attach to the chain. Thank you. How do I say it? Erger. Welcome to the channel. Hope you're having a lovely evening. Are you a game developer? Are you just wanting to learn? Are you sort of a programmer by profession? Gamer by night? Curious. So let me know. Honestly, thanks for follow. I appreciate it. Just getting started on this, so it's hard to get out there. The internet is a massive echo chamber sometimes. So okay, so if we have no links yet, then the link target is going to be the chain itself. I think that makes sense. Now, why are you complaining? The argument letter is never used. Oh yeah, okay. So the link. Let's have a look. So the chain link. Whoa. Another resource is loaded from path. Play. I don't know what that's complaining about. We'll find out soon enough. Okay, so the chain link has a character value, right? So if we say the link.character, okay, so we create a new link, right? And we say the new link dot character is equal to the letter. I mean, maybe that's I don't know whether we should be calling these characters or letters. I'd like to probably have a consistent terminology, but maybe not tonight. Yeah, okay, so at least for this can be a character, and this can also be a character. And then we add it, it attaches to the next link target, and if it's not that, then it is links dot size, or is there a last? Links dot find last. What does find last do? Searches the array in reverse order for a value and returns it. Okay. Godot array last. There's no helper method for this, I don't think. Just oh, -1. Okay, yep, that'll do. So we return that otherwise. Okay. And then each link has an attached to that we need to implement. So let's go into here. And we need a new function called attach to, and that's going to be a node of some variety. And what we're going to need to do, I believe, is grab the pin joint and set node B to, yep, cool. So what we need is a new onReady variable, and we'll call this joint, and that's going to be equal to the pin joint 2D, right? OnReady var joint equals pin joint 2D, and when we attach to a node, all we do is we set the joint dot node B equal to node, right? Okay, let's see if all of this works. I'm not confident. The argument character is never used in the function addLink. Okay, let's just clear out all of this stuff. What is that little? Okay. Let's see how we get on. Okay. Bloop. Oops, something went wrong. Non-existent function length. Okay. Set state. Size. Right. And let's call this size as well, just for consistency. And in player, are we gonna, do we have any length in here? Whoops. Length. Nope. And chain we do. So we're going to call size there and size there. Getting confused with our JavaScript project. Okay. Let's try again. Size isn't declared on base string. Okay. So strings have length and arrays have size. Cool, bro. Alright, here we go. Come on, come on, come on. Oh, come on. Invalid set index node B with value type. Rigid body. Really? Come on, guys. Okay, let's have a look at this pin joint documentation. Maybe we are getting mixed up. Pin joint 2D. Inherits from joint 2D, okay. Oh, we're supposed to set a node path. Okay. Godot.get node path from node. Node.get node. Hello, Vapug. Thank you for the follow. How are you going this evening? Let me know if you're a dev and what sort of stuff you're into. Are you more of a fan of the Elixir side of things, or are you more interested in the Godot game side of things? We haven't done a lot of Elixir tonight. We did a bit more a couple of nights ago. It was pretty much all Elixir. But I'm interested to see what you guys are up to. Okay, so instead of just doing the node, can we do node? So that's going to be a node 2D, and so can we call node.get path? Is that going to work? Plunk. Yes. Okay, so we got our first letter, but it's connected. It's connected to my bum. It should be connected. Okay. We need to figure out how to connect them relative. This is getting insane. That's not what's supposed to happen. I mean, it's almost what's supposed to happen. I think I just accidentally invented Katamari Damacy. Okay, so it does look like we're not adding individual characters to the chain. We're adding all the characters at different points. Like, I'm not entirely sure why. I wonder if maybe we should just disable this network. Return. So Clink. So what do we want to do? I guess we need to specify where the chain links are supposed to connect to. And maybe stick that even further out. like a -40. And maybe bring the collision shape in a little bit. Maybe that was a bit too much, but and maybe 18. Okay. And I might bring that over the sprite so we can see it a little better. Cool. Now we can hide it. It's not important anymore. All right, so that pin is going to pin there. And I think what we want to do actually is bring everything down, right? So we're going to move that to there. And then we need something that represents that, like, I guess we can just use a node 2D. Right, and we can just call this link position, right? And then we can move this down by about, what, 60? Maybe more, 75? Okay, so that 75 is going to be our link position, and so when we attach to the node, I don't know. How do we want to do it? Make a Fortnite game. I think there is already a Fortnite game. I mean, we could make the level slowly get smaller as time goes on. That's a pretty cool idea. I mean, it's been overdone in the last couple of years, but we could definitely do it. I mean, it would be nice to keep the players like clustered together. I was thinking that we could just sort of apply gravity so that all the players essentially just automatically gravitate to each other, and then you don't need anything else, right? They all just sort of gravitate. I don't know. Who knows, man? The future is full of possibilities. Okay, so okay, if I open this chain here, so we can probably pull all of this chain stuff down as well, right? Oops. Okay, and then we'll just unselect that pin joint and go a little further down as well. Okay. And now what? Maybe move that up slightly. Oh, not that one. Move that up to about there. Yeah. Cool, we don't need that collision shape anymore. And And then, so our chain link has a link position. So I'm gonna, what am I gonna do? Duplicate and nope, that's no good. Delete. Okay, so we can create a link position here. So it's just another node 2D. We'll call that link position, and we'll bring that right down as well. That's about a 70, maybe closer to an 85. Yep. Okay. And so let's think about this. So when we create a link, okay, so let's have a look here. So what we can do is we can save the target in a variable, right? We can attach it to the target, and then new link dot position dot okay. So we attach it, and then we say the new link dot position is equal to the target dot get node. Nope, not get node. Dot. Oh, I'm gonna have to check the docs. Node 2D. Do you play a lot of Fortnite then, Vapug? Vipug? To the global, maybe you just set it to the global position. Okay, so we always want to look at the player, right? Once we do that, so we can say new link dot look at okay. Maybe not right now. Okay. No. Nope. So we actually want the node object, right? Okay. So the node object at a certain point, and then we want to find node. Find node whose name is find node. Okay. I think that'll work. So we attach to the target and we go target.find node link position, right? So we can say the var link position is equal to that, right? And then we say new link dot to local the link position to global. Right, let's see if this works. Not quite. Oh dear. Let me think. Well, it might be getting a bit too late to think. Okay, so whoa. So let's verify that we're actually finding this link position. So let's just print that out. Found link position. Link position. I mean, we could just say instead of doing this, we could just say that the new link position is equal to the target position position. Whoa, okay, I'm definitely tired. Position. That doesn't look position. Oh man, I'm so tired. Yeah, I need to finish up. Okay, so new link dot position is equal to the target position. Let's see how far we get with just that simple naive code. No, so everything is going to be at the same position as the player, right? Okay, and I think these chain links have a colliding pin joint, right? Softness. Okay, we need a little bit of softness, otherwise we go crazy. Okay. I think we've made good progress. Right, like, not amazing progress, but we just need to fix the position of the chains. I mean, we could make them children of each other, but that might be a bit weird. Zoomies, zoomy. Okay, cool. So we are finding the node 2D. Maybe I'm just going to open a debugger, a breakpoint here, and see what we get. Breakpoint, click, okay. So our link position is what? Path main. Chain link position. So it should actually be relative to the player, right? Yeah, okay, I think that's me done. I'll commit this and we'll figure it out next stream. Okay, so let's discard that hunk. We can say generating chain links, right? And let's push that up. And let's do a little bit of a debrief, shall we? Alright, so this evening we managed to get our chain generating individual links. Unfortunately, the position is still not quite right, but I think that's relatively simple to fix. I just need to think about it after a little bit of sleep. If you're interested in following the project, check out the Twitter account. We'll be posting highlights of these streams and tutorials on the YouTube channel. It's all down the bottom there if you're interested. Also, sebthecat.com is the blog. We have a Discord channel, so if you're interested in making games and you need some help, there is people requested a Discord channel so that they could essentially have a community where they can get help when they're making their own games. So check that out. Don't forget to give us a follow if you haven't, and as always, I think you should take it very, very easy. Have a lovely weekend, and ciao.